Okay, as usual, we take the attendance again. Okay, let's take the attendance. Okay. So now please do the part D, finish it off, get your answer. Let's see, you get the answer you obtain is plus minus 10% of the answer. I'm going to show you now.
If I keep it in a 3 answer.
Yeah, keep it as 3 answer. Keep it as 3 answer. Okay, so yeah, so you should get around 8, but put it 3 answer. Okay, go for 3 answer. Standardized 3 answer. So here you've got 8, 8.00. Okay, go for 3 answer. So plus minus 10% of 8, if it's within that range, so you will get the accuracy mark. Okay, 1 marks normally go for the accuracy. Okay, out of how many marks? This paper 5, total is 30 marks, 2 questions. This is one of the question, 15 marks. This question is 15 marks. So out of 15, 1 mark is go for. Most of the time is accuracy. Okay. Okay, out of 30 marks, this first half, you must score. This is easy compared to the next half. The next half is design experiment. Okay, it's completely subjective. Okay, so most of the time, students out of 15 of the next part, they usually they get average of 9, 10, 9 or 10. So here you have to score at least 13 to 14. Okay. Okay. Yeah. So by using this formula, you substitute the changes of R and R. Okay, what is your changes of R and R here? How do you substitute? Changes of R over R in the graph, what they give you? The graph. Okay, yeah, sorry. So the part D, they say R is 5%. Okay, they say R is 5%. That means changes of R over R, you write as 0.05 fractional uncertainty. 5% is changes of R over R times 100%. So changes of R over R, straight away you put 0.05. So yeah. So here, of course, so this should be 0.05. 0.05. Changes of MOM, your uncertainty for the gradient and the gradient. C, whatever C you obtained earlier, from this, get your C, right? Okay, substitute your C, get the changes of C. Okay. Most of the time they will tell you, as I said, if 3 marks allocated here, most probably what they're going to give to 3 marks is method. Method give 2 marks. Okay, let's say. Give 2 marks for the method. Method means you want to see, is it the equation correct? Yeah, is this equation correct? You put changes of R over R as 0.05. The method, you get marks. Okay, most of the time. Okay, 1 mark go for the range. Okay. Sometimes they don't give range only. Sometimes they didn't give the range. Completely goes for method. Okay. So check the method is correct. Okay. No marks given for the error at all. Whatever error you got here, no marks given for that error. The marks given sometimes for the value within the range, sometimes. Okay. Most of the time, of course, goes for method. Okay. Formulation must be correct, the substitution must be correct. Method. And 1 marks go for the, sometimes go for the unique. Okay. Final unique. Okay. Okay, I don't know how many of you done this graph. Okay. Looks like many didn't do the graph. Okay. So we have about, we done past already 20 minutes. Okay. So I just give you 40 minutes. Okay. We do brand new one question. 40 minutes, finish up completely. Okay. You have the graph papers. How many of you have the graph papers with you? Anyone needs extra graph papers? You can get it from here. Okay. You have some graph papers. These are the graph papers. Take one. Okay. So assuming like in the exam, one question, you go for C4. Okay. Okay, 40 minutes, real examination. Real examination, the paper is 1 hour 15 minutes for 2 questions. So 1 hour 15 minutes. This question, you try to finish in half an hour, maybe 45 minutes for the next question, design. Okay. But today, because first time you're doing by your own, I give you 40 minutes. Okay. So 40 minutes. Okay, we stop at 12.5 and 12.5. Okay, read the question C4. Try to fill up the table. Okay, follow the idea I told you. First question, yeah, as usual. Explain why plotting a graph of R against L squared would enable us to confirm the relationship between R and L. Okay, use your linear law, rearrange this equation, then only we are able to find what is gradient, what is your intercept, right? Because they want to plot R versus L squared. So your y equals to mx plus c, your y must be your R, your x must be L squared, right? So expand this, rearrange it so that your left side, your y is only R, and you have L squared. So you know our linear law, right? Yeah. Okay, tell me what is gradient, what is intercept?
The resistivity is fixed, right?
Yeah.
Rho is fixed. Also.
Yeah, rho is fixed. R naught is fixed. The last 40 minutes, eh? Come on. Wow.
What are the options?
I give you the marbles. Okay, class, you're going to plot R versus L squared, Yeah. So tell me what's the gradient, what's the intercept? Of course, should be a straight line.
So how do you turn that into a straight line?
Yep.
Formula into a straight line.
How it becomes straight line? We have to arrange the equation first. So rho L squared, it always become a straight line. So R minus R naught, right? So we'll bring the other side. R rho L squared over V plus R naught, right?
Oh, okay. How do we answer the first question? How are we supposed to write it?
Yeah, by obtaining a straight line where the gradient is this, y-intercept is this, will enable us to confirm the relationship.
So is this box for L square and then this line for the uncertainty? Is this the uncertainty and then this is the normal
Yeah,
line?
because two column, right? Okay, last. So what's the first answer you got for the gradient? Gradient, you got rho V. So you got rho V, Intercept, you got R naught. Intercept R naught.
Could you please explain why you rearrange the formula?
Yep.
Why did you rearrange the formula?
Because they asked to plot R versus L squared.
Okay,
So we need to arrange it such a way that R is your R, X is your L squared.
so it's like why is
Y equals to mx plus
C in that format? So
whatever beside the L squared will be presenting the gradient.
okay. So what's your grade? M is equal to your V,
M equals to rho V.
and your y-intercept is
R naught. This is standard every time.
And then we just use the points that we got and we plot it into a graph. Anything else we have to do? I mean, apart from the next question, calculate.
That's fit per speed.
Oh, sorry?
That's speed line per speed line. You need to draw the best speed
Oh,
line.
okay. So the points will be irregular and we have to plot it as and for the second part, for part B, calculate in the part.
Chase of R, you have chase y squared, you have two techniques, right? You
Yeah.
can make an equation
Yeah.
or the maximum minus the actual.
Okay. So we can do one of those two.
One of the
and plot the points on the table. Thank you.
Well, so the first answer should be what? By obtaining a straight line where gradient is rho V and y-intercept R naught would enable us to confirm the relationship. So all of you got this right? By obtaining a straight line where gradient is rho V and y-intercept is R naught would enable us to confirm the relationship. Okay. So as I said, recent papers, they just ask what is gradient, what is intercept, that's it. So you must get able to get what is gradient and intercept represents. Okay, now use the two method I taught you, either by forming the equation or the extreme value minus the actual to find the uncertainty for L squared. So get your data, then I show you the data, what you should get. Okay. Don't proceed to the graph yet. Okay, just get your data first. So part B they say include in your table L squared and the absolute error for L squared. So you have two columns. So one go for L squared, another one is for changes of L squared, right? Yeah. So you only have two columns, right? R versus. So of course the first one is goes for what? L squared, and this is for L squared / centimeter squared. The other one is changes of L squared / of course centimeter squared. Because you have two columns. So you're going to make one column empty. You want to make it one column empty. Can, but they only have one. So easy. Okay, so yeah, L squared, centimeter squared, changes L squared, centimeter squared. You now get your data by using the two, there are two ideas, right? You can use equation, create an equation, y equals to L squared. Or use the extreme value minus the actual value. Two methods, right? I taught you. Okay, so now you want to find the changes of L squared. So what is the method? Maybe I go for the extreme minus the actual. So how do you find the changes of L squared? So L squared maximum, okay, maximum L squared minus the actual L squared, right? One method. L squared maximum minus L squared the actual. For the first data, what is the maximum L squared can be? First data, the L is 6, 6, so 6 plus minus 0.4. So what is the maximum L squared can be? 6.4 squared, right? 6.4 squared minus L actual is what? For the first data, 6, so 6 squared. Yeah. So 6.4 squared minus 6 squared. Whatever answer you got here, that should be your first reading, right? Changes of L squared. One of the method, maximum L squared minus the actual L squared will give you the uncertainty for L squared, right? One of the method. Extreme minus the actual for L squared will give you the uncertainty. Okay. Okay, now please get your data. Get this 6, 12 altogether. Get your reading first. Then I show you the answer. See, you get that the same value as the answer. Then correct. Another method. What you can do? Another method. You want to find uncertainty for L squared. You just say y equals to L squared. Okay. Second method lah. Second method. This is the second method. This is the first method. Second method. So changes of y over y is what? 2 changes of L over L. So changes of y is what? 2 changes of L over L multiplied by y. So 2 changes of L over L. Y is what? Y is L squared, right? L squared. So at the end, what do you get? The equation changes of Y is 2 changes of L. Okay, this is the formula. Can you use this formula also to find your uncertainty? Okay, that means the first data 2 times changes of L 0.4 times with L 6. 2 times 0.4 times 6 will give you the uncertainty. Another method. The choice is yours. Any one method, get up. Okay. So first step, try to get the values correctly. I'll show you the answer. Okay, give you 2 minutes, complete your data. Get your data first. Okay, so you get this data. L squared, get these values. Correct significant figure, right? Your first coordinate, first data is 2 significant figure, 36. Okay, why 2? Your original data is 2 SF, is it? What's your first L value? Yeah? 3 SF.
First is 2, second.
First is 2 SF, right? 6.01. So yeah, 1 by 1. L squared is first reading is 6.0, right? So 2 SF, right? So L squared must be 36 lah. You write 36.0 still accepted. One extra significant figure accepted. Okay. 4 wrong. So here 36. Next 100. Second how much? 3 SF. So 3 SF. So 100 can be 1, 2, 3 SF, right? Okay. The 0, 0 we can consider as SF, or don't want to accept as SF also can. So 100 is can consider as 3 SF, right? The 2 zeros like a joker. Okay. Yeah, so this is how your significant figure should be. Okay. So L squared you get this, Follow the significant figure of your source. Okay, it follows individually. Maybe the first data 2 SF, maybe the last data is 3 SF, so you have to go for 3 SF for the last data. The first data may be 2 SF. So they follow their own source. Okay, significant figure. So significant can vary and depend on the source. Okay. Okay, so before we plot graph, I show you the error. Okay, the important is the error. Error, do you get these values? For errors, do you get this? They give two choice between 4.6 to 5. because two methods can be used. Can. Arrow, you got this range? Suppose you follow the decimal place of your value.
Zero decimal place.
Zero decimal place, so no need to put any. Doesn't matter. Okay. So Arrow, you got this? First error, what do you got? First error, you got 5. By using the max minus actual. So you got all correct. Second one, what do you got? You got 8. 8.0.
I think it was 8 point something, but I roughed it off.
So you round it to 8.2.
But we only follow new reading.
Oh yeah. First readings, what?
There's no decimal place.
Yeah, 8. 7.8 to 8.2 lah, accepted. Okay, class, 7.8 to 8.2, you can have in between, doesn't matter. 8, 8.1, 7.9, accepted. Okay, 7.8 to 8.2 should be your answer. Okay. So because your second reading is 100, second reading is 100, so plus minus 8. Okay, we follow the same decimal place. 100 plus minus 8. Okay. Okay, the error should be in between this. Okay. Here they put 7.8 to 8.2 in between 10. But you see the last one, 20 or 21. Now this one only can be 20 or 21 only. Okay. Last one, what do you got? You got 21. Okay. Why they give two values? Because two different methods. So they give both answers accepted. Okay. Okay, class, so now you have your data. You now go ahead, plot the best fit line, worst fit line, and the error bar. Okay, go back to the question. The scale is provided to you. Okay, this is how it's going to be in your exam. Scale is there. Okay, scale is already provided. Just draw the best fit line, worst fit line. Okay, and draw the error bar. Okay, after you draw your best fit line, worst fit line, just raise up your hand. Let me have a look. Your best fit and your worst fit. Okay. Draw the graph. After you're done, don't proceed yet. Just let me see your graph first. Okay. Best fit line and the worst fit line. Yeah.
Yeah, the value. What the error values like that? How come suddenly 2 as 7, some 1 as 7?
They can have more than one asset allowed.
So if it's 10.0, right? That's 3 as 7.
Yeah.
Yes.
Yes. But follow the decimal place of this one. It's 36, right? So if I were you, you got 5.
It's 4.96, so you round up there and become. Oh wait, yeah, because it's 2 as 7 here, so I have
so you just write 5. You can leave it as 5.
Oh,
same decimal place.
Oh, same decimal place. Oh, okay.
Same decimal place. The first one is 5. Second one is this is no decimal place, right? So 8.
I thought this one follow SF also.
No, this one follow the decimal place of the value.
What? So that means what? So how do you determine this one, sir?
The two method I show you.
No, not determine like the final answer.
The final answer, you follow the decimal place of this one.
Decimal place.
There's no decimal place, right?
Yeah.
So here you just write 8.
8 is enough.
8 is enough.
Then here will be 11.
11, yeah.
Oh.
Follow the same decimal place of your value.
Just want to confirm. So like the error bar in L square is
In this case, L is your x-axis.
yeah.
So horizontal error bar.
Okay.
Okay, class. So axis is already in your graph, right? Okay, check in the question in the lab manual. There is a graph there. The scale is already there. It's already stated over there. Because some of you using a different graph paper, external graph paper. Yes, this is your scale, right? Okay, use this scale, Okay, so those who have a separate graph paper, please use this scale. Okay, the previous questions, we got vertical error bar. This one, we have a horizontal error bar. This is horizontal error bar, right? Because L squared got error. So your graphs all going to be like this. I think you're going to get error bar like this, horizontal error bar, right? You got like this. I don't know, just drawing roughly.
Drawing the worst fit line, do we go for the worst gradient, the steepest gradient or the less steep gradient?
Your choice, the extreme one. Normally you go for the steepest.
I don't know. Where is it?
Oh no, this one. Oh yeah.
I can just leave it without decimal place, right?
Yeah,
Okay.
14.
So
Same
for
decimal place of the line.
the top one, I leave 5 also can, no?
Yeah.
Do I need to put 0.0?
No need.
Okay.
Because, yeah. You must draw the best field line, and as usual, the worst field line, you must draw the greatest gradient within the error bar. It must cut all the error bar.
If we label our lines like this, would they know like the top one is the best and bottom one is the worst?
Put a arrow
Arrow.
pointing that.
Is it okay?
Okay. Sweet, okay. The error bar is very small,
Yeah, because of the scale.
It should be identical to everyone. Check the others, but the same length.
So for this value is plus minus 5. But then I don't have enough space on this side. Plus minus 5.
Your actual reading is how much? Actually, it's 36, so maximum become 41, right?
Yeah, but then like I don't have
41.
like minus 5, I don't have enough space.
But it cannot be. One small box is 10. Class, once you're done with the best fit, worst fit, show me. Okay, your graph must be exactly identical to your friend, right? Because same data, the error bar length must be about the same compared to your friends. Right? You got longer error bar, your friend got a shorter one, all of you wrong. Well, because this error bar is horizontal, how to get the greatest gradient? As usual, so you get this corner. You place your ruler at the right corner of the first error bar, and the left corner of the highest error bar. Put your ruler. Place your ruler like this. Okay. So this is going to be the greatest gradient, right? Difficult for me to draw straight line. So the right of the first error bar, put your ruler, and the left of your top error bar, place your ruler across. That should be the greatest gradient, but make sure it crosses all the error bar. If any error bar does not crosses, then what do you do? The bottom you make it as a pivot. Don't move that ruler. The top just adjust it little down until it crosses this error bar. Okay. So if your worst fit line doesn't pass through any one of the error bar, then it's wrong. So again, you want to draw the greatest gradient. You place your ruler on the right corner of the first error bar here, okay, and go to the last what do you call error bar. Place your ruler at the edge of the ruler at the left. Then when you place your ruler like this, okay, this is your ruler, okay, check is it cuts all the error bar. Okay, let's see one error bar is somewhere here, okay, so it doesn't cut. What do? So bottom you make it like a pivot. Don't turn it. Don't change this. At the top one you just move it a little down until it cuts here. Greatest gradient. Okay, show me what is done there. Because this is important. Graph of paper. Real exam, try So if it cuts the object over We can't rely for this solid area because the best fit line is now. Because once you already got your best fit and worst fit, now you can proceed with the questions. Now, first thing you have to do, draw the two triangle for the best fit and the worst fit, get the gradients. Okay? Get the gradient and y-intercept. Okay, get your gradient and with its uncertainty. So find the gradient of the best fit. 2 minus y1, x2 minus x1. Okay. Yeah.
Can we label the lines in the graph?
Yeah. Okay.
Okay.
So you meant for the
Square of an arrow is
this is the last one. Yeah, you cut at the junction, right? Like, you know, here, you see here, this is the arrow. So you have to cut here, right? You cannot cut here. That's the main thing. My vision is bad, so that's why I couldn't. So hope you cut here. Here. You must touch the horizontal. Class, you're working math, gradient of best fit, gradient of worst fit. Then your answer is the best fit gradient is the answer. Your uncertainty is the best fit gradient minus worst fit. Okay. So this is expected 3 significant figure. Okay, plus minus your error. You must clearly show the method, the method given mark. Okay.
For answer, we have to put in standard form.
Yeah, good practice. Good practice.
Even if it's just 10 to the power negative 1.
That's okay. It's quite a big one, then right.
In this case, I got the gradient as 0.55 and the uncertainty is 0.01.
This is fine. Not necessary. Quite what just 1 or 2 only. It's quite big then. Like 4, 5, yeah. So I believe you're done with your gradient. Now go ahead with your intercept. Do the same thing for y-intercept. Get your answers for y-intercept.
Yeah, but what's the split line? Almost like a bicycle line.
Yeah, because your error bar is quite small. Because it's going to be identical to everyone.
Yeah, we'll get tissues.
Years ago,
Oh, sorry. This question they never asked for y-intercept. Okay, I think this question they never asked for y-intercept. They just asked for the gradient only. Okay. Okay, so once you got your gradient, now this is the difficult part normally. Okay, think about how you're going to do the part D now. Okay, normally the last part after your gradient and intercept is going to be extra calculation. So there, it could be a little tricky. But as what we did earlier for C3, the same thing happens here. Okay, so here they're asking for the volume of the conducting putty was 18.8. Volume was given 18.8 centimeter cube. Determine the value of resist density, right? In this case, density. Include the error and unit in your answer.
So how do you find the uncertainty?
Okay, so yeah, the problem is how do you find the uncertainty for the rho? Yeah. But what's the question? What is the gradient you got? Gradient is what? No, I mean the equation. Gradient represents what?
Sorry?
The equation. Gradient is
The gradient is rho over v.
gradient is rho V. Okay. Gradient is rho.
But we don't have the uncertainty for v.
But they didn't give one, so we assume we don't have uncertainty. Because they didn't give one for us.
So what are we supposed to do?
So because we don't have uncertainty, so we don't have uncertainty, so it won't include in the equation. Okay, class. So let me brief everyone. Okay. So how are you going to find the rho and uncertainty for the rho here? Okay. So you have to go and refer to the gradient and intercept you obtain. Okay. What is the gradient you obtain for the gradient is what equation? The gradient equals what? Rho V, right? Okay. So you know gradient is, okay class, come on. Focus first, 5 minutes, important. Part D, So gradient is rho V, you want to find the rho and its uncertainty, okay? So rho is what? Rho is gradient multiplied by V. So you know the volume is given 18.8 centimeter cube. So you can key in here 18.8 centimeter cube, or you want to change to meter cube, can. But do they give unit at the bottom? They never tell any unit, right? So you can leave it as centimeter cube, okay, just 18.8. And the gradient, whatever gradient you got. Okay, now how do you find the changes of rho? So from this equation, right? So gradient got uncertainty, but volume, is there any uncertainty given? Volume, did they say plus minus anything? They never stated anything, just said it's 18.8, definite. So no uncertainty for volume, okay? So that uncertainty for rho is only depend to what causes uncertainty for the rho? Just the gradient, right? So can you write the equation now? Uncertainty equation? That's all. Yeah. So this is the equation. Okay. So this is the equation. Changes of rho is changes of m over m, because we don't have any uncertainty. So from here you work out your changes of rho. So changes of rho is changes of m over m multiplied by whatever density you got here, right? Yeah. So you can find changes of rho. So the unit here, the V use centimeter cube. Your gradient is what unit? Gradient what versus what you plotted? Gradient you plotted R versus L squared. So R versus L squared, ohm per meter squared. So this is ohm per meter per centimeter, right? Centimeter squared or centimeter? Centimeter squared, right? So finally, what's the unit? Ohm cm, ohm cm. Okay, the unit for the rho is ohm cm, right? So ohm cm. Okay, in the answer, they never specify any unit. They never specify any unit. You just carry on with the unit given by them. They say give centimeter square, just continue. Don't convert. Conversion might give you more problem, right? So you just continue with their unit. Okay. So work out your answer D. Okay, complete the report. Now I show you the mark scheme. Let's see how many marks you get. Okay, 15 out of 15. But first complete your answer first for the D. Class, please complete the part D. Complete the report now. Get all your answers. After your graph, all your answers go for 3 significant figure. The uncertainty follow the decimal place of your value. Okay. Okay, I give you 5 minutes to complete.
Why is it so big? Wait, you
Okay, so I hope you got your entire report done. So let's see how many marks you get. Okay. So I go to the mark scheme. Okay, see how the mark scheme allocated the marks. Okay. So take a pencil, you can mark yourself. Error for the volume. Because volume they never give any error. So we assume it's a definite value number without any error. So 0. No error. Relax. Okay, let's mark yourself. Okay, tick down which part you lose mark. Okay, out of 15. Okay. Okay. So the first mark goes for your correct ingredient, correct comment. This mark is not called for R. So first mark goes for the what is gradient? Rho V. What is intercept? Y intercept? R not. Right? I discussed with you one. So you get this one mark. Okay. Okay, next.
Do you have to include the equation formula inside the A?
Not necessary.
So we just mentioned that what's the gradient and
What is
what's
the
the y
gradient?
intercept.
Yeah. Better to include 2 lines.
Sorry?
Better to include 2 if you want.
So include the full formula as well.
Final format. Hey class. Next mark, 1 mark, check. The column heading L squared / centimeter squared. This also we discussed. The changes of L squared / centimeter squared. So heading, 1 mark. Okay. Okay, next, value of L squared, we already discussed, should be correct. If all the readings is correct, then you get 1 mark. Okay. 3 significant figures needed, except for the first row. First row is 2 significant figure, right? Allow for SF, 1 extra allow. Okay, extra allow. All correct for 1 mark. Only 1 mark for your data. Okay, for graph 3 marks. Okay, to check all which marks must be half a small square, indicate an error. So all points are transferred correctly. Correctly. Line of best fit must be within the tolerance. So line of best fit in the reason papers. The reason papers for the line of best fit, they give coordinate. They give a range where the line should pass through. Okay, the bottom and top, they give a range. Okay, in this paper they didn't give. So current papers they give a range. The best fit line must pass through that range. Okay, line of best fit 1 mark. Worst acceptable straight line must be within the tolerance, must pass through all the error bars. Okay. Yeah, you have to label. At the end, you label which is best fit, which is worst fit. Yeah, with an arrow. Okay.
What's a broken line?
Allow broken line. Like you are drawing like a dotted lines, not a continuous line. So they allow. But draw continuous line, that's the best. Okay, class. So gradient best fit line, the range is, you get this range. If within this range, so you get the gradient mark, 1 mark. Okay. 3 significant figure. Always 3 SL. After the graph, all go for 3 SL. Okay, that's 1 mark. Okay, next. Value of rho, gradient rho V is used. Okay. And yeah, the value is 10.3 to 10.6, the range. Okay. So you out of this range, you lose this 1 mark for rho. Okay, must be 10.3 to 10.6. So you need for rho 1 mark, ohm centimeter 1 mark.
No uncertainty.
Next slide. Uncertainty will go to the next part. Okay. So take down the values, 10.3 to 10.6 for your rho, gradient is 0.55, 0.56 in between. Okay. All go for 3 SL. Okay, next. The error, I already discussed this. Okay, this is 1 mark. Okay, error bars aspect plotted correctly, so they're going to check the horizontal line, the length is correct. Okay, then you get 1 mark. Error in gradient, you see error in gradient, they don't care what is the value you got, but the method. Okay, so you did best fit gradient minus the worst fit gradient, whatever value you got, so you get 1 mark. Method. Okay, 1 mark. Okay. So next, error for the row, the worst gradient times the volume minus the row. Worst gradient times volume. It's only method given, Okay, class, by using the method I told you, the formula, what is the answer you got? Is it fall in unity?
Yes.
What do you got? 0.4. Yeah, 0.62. Your values, how many 3 SF, right? Write your error, the same decimal place. How many decimal place went? 1. 3. 1 decimal place. So you get 0.6, right? So okay, 0.6.
If I follow their method, I get 0.3.
For the 2 methods. 0.3 what? 36 or 34.
why is their method for calculating error this way?
Plus gradient times volume. Plus gradient times volume. Oh, this is your extreme. Hey class. Hey class. You might. I told you to find your error for the row. Follow the formula. You make the equation, right? That's one method. Another one method. The one I showed here. Okay. Another one method. But this method is not really followed the current papers. This method, the extreme row minus the actual. This is the extreme row, right? How do you get row? Row is mass gradient times the volume, right? Maximum row, how do you get? Maximum gradient times the maximum volume. But volume don't have maximum, just volume. So maximum gradient, worst gradient is the maximum gradient, right? The maximum gradient times the volume plus the maximum gradient times the volume is the maximum row minus the actual row. Also, you get uncertainty for the row, right? Yeah. Yeah, both method. But the current papers, the mark scheme, they only give the formula method. So you follow the formula method. Both method accepted. Okay. Okay, so this is total 15 marks. Now you should know where you're losing your marks, so correct it. Okay, you must get at least 13 or 14. Okay, because design is a little tough for you to score full. Okay. Any questions?
For the uncertainty of gradient, we use the high one minus the low one, right? Not necessarily best fit minus the worst fit.
Higher
The
minus the
higher
actual.
value minus the lower
Actual.
value. Uh, 'cause
Actual, right?
in this case, they're saying best fit minus worst fit. But I use worst fit minus best
No,
fit.
this one. Check method. Gradient best fit minus the gradient of worst sector.
Can it be another way around?
Another baby?
Means worst fit minus best fit.
Worst fit minus best fit. Also, you get a negative or plus answer. Same.
Same right.
Because plus minus.
But try to get the plus one.
Both the acceptable. But normally, because it's plus minus, you got negative also. Okay, class. So we have about 30 minutes. You have class after this? 12 o'clock. Yes, we have class after this. You always. So we spent just 20 minutes now. Just 20 minutes. I stop at 11:50. Is it okay? 11:45, 11:50. Just these 15 minutes. What we're going to do is we just finish off the capacitor. Just 4 to 5 lines only. Yeah. The previous capacitor topic we done right in the theory. We just a little to go. Okay. Yeah. The theory. Yeah. Just little to go. We cover up this class. Just 20 minutes. Okay. Yeah. Yeah. So D. D, you have two methods, right? One is the formula you understand, right? The formula you understand, right? The other method is the extreme, the maximum row minus the actual row. This is your maximum row, right? Row is gradient times volume. So gradient, you take the maximum gradient. First gradient is the maximum gradient. The maximum gradient times the volume will give you the maximum row, right? The maximum row minus the actual row, you get the uncertainty for the whole.
For part A, must we include would enable us to confirm the relationship?
Yeah.
For part A, do we have to write would enable us to confirm the relationship?
Yeah.
We must
But
write.
coming exams, all the current paper, all just what is gradient, what is it? You must hear what is need to tell in the short form. Straight line, gradient is this, C is this. Just enough. No, straight line. By obtaining a straight line. by obtaining a signal.
One day this is gonna get seriously bad, and you guys gonna criticize. Whoa. Oh, yeah.
Hey guys, just 15 minutes. Last part.
So I need to get my
Okay. Okay, so capacitor, we learned the amount of charge stored per unit volt, right? C. Then we talk about what is series parallel, okay, how the capacitor connects to series parallel, how the capacitance change. You want to get lots of capacitance, you connect the capacitor in. You want to get the greatest capacitance, you connect them in series or parallel. You connect them in parallel. Parallel capacitance increases. Okay, then the last what we learned that day, how much of energy is stored. Okay, so the energy stored is found to be half QV, half Q naught V naught. Okay, so the battery releases Q naught V naught, but the capacitor only store half of it. Okay, efficiency is found to be 50%. So this tells that this slide tells that energy loss of a charging capacitor 50% loss. Where is it lost? As energy is lost as heat in the connecting wires. Okay, you blame to the connecting wires. Okay, energy lost to the connecting wires. Okay, okay, we stop there. So now something new, just a little to go. Okay, okay, let's try this one example first. Okay, look at this example. You have 100 microfarad, 6 volt, and you have 20 kilo ohm resistor. You are charging the capacitor. Okay, just get the ideas. How do you go about? First question. In the circuit shown, a switch closed sometime later. The emitter reads 210 microampere. Sorry, the emitter reads 210 microampere halfway through. Not fully charged, right? And the capacitor is fully charged. The current become how much? 0. So this is halfway. Halfway, the current found to be 210 microampere. Calculate for that instant. At this moment, calculate what is the PD across the resistor. What formula do you use? Anybody? If you fast, we can finish it fast. PD across resistor. How much is the PD across resistor when the current is 210 microampere? What formula? V equals to IR. V equals to IR to be used. I is 210 times 10 power negative 6. Resistance is what? 20 kilo ohm. 20 times 10 power of 3. You get the PD across resistor. Right? Okay, the formula must come to mind. V equals to IR. Okay. How do you get PD across capacitor? How do you get PD across capacitor? Anybody? PD across resistor, V equals to IR at this moment. 210 microampere current flows. How do you find PD across capacitor? What is the total PD? 6 volt. So, Kirchhoff, first law, second law. Total EMF is the total PD, right? Across all the, in this case, resistor and the capacitor. So, how do you get PD across the capacitor? 6 volt minus PD across the resistor. Okay, PD across the resistor and capacitor add up should be 6 volt. Okay, capacitor plus the resistor PD add up should be the total voltage 6 volt. Okay, so how do you get PD across the capacitor? The total voltage 6 minus the voltage across resistor will give you the PD across the capacitor. Okay, who shares the voltage of the battery? The capacitor and the resistor. Okay, so when the time runs, the capacitor voltage will rise, the resistance voltage will decreases to 0. Okay, so after completely charged, capacitor will be same voltage as the battery. Okay. Okay, that's the second one. PD across the capacitor. 0. Should be 6 volt minus the whatever PD you got here, right? So this is the PD across the capacitor, right?
So once the capacitor is like same voltage, that means there won't be any more current, right?
No current. Because the capacitor polarity is opposing the polarity of the battery, current won't flow. Okay, so that's A. Okay. B, when the capacitor has become fully charged, calculate the energy stored in the capacitor. What formula? The capacitor fully charged. What is the energy stored in the capacitor? So new formula, right? Learn. So what are the things you know? You know the voltage is 6 volt and the capacitance, you know, 100 microfarad. So what formula do you use? Energy equals to, in terms of C and V is the most suitable, right? You know the voltage across the capacitor. So R CV squared has come to your mind, right? The energy stored in the capacitor. R CV squared. Okay. C is how much? C is 100 microfarad. So times 10 power negative 6. I'll change to farad. V is what? V should be same as the voltage across the battery. 6 volt. Will be voltage across the battery. So the energy stored will be R 100 times 10 power of negative 6 multiplied by what? 6 squared. 6 squared. 6 volt. So this formula must come to your mind. I'll say it's joule, as usual. Okay, energy stored of CV squared. You have 3 formulas, but here I think suitable is CV squared. C we know, V we know. Because we don't know the charge, we ignore that formulas. You already find the 2, last one. What is the total energy taken from the battery? Whatever energy you got in 1 times what? Times 2. You get the total energy released by the battery. Okay. Energy released by the battery is 2 times greater than the energy stored by the capacitor. Okay. QE of QE. Okay. So whatever answer in 1 times 2, you get the answer for this. Okay. Okay, so this is the idea must be in your mind. So the working is here. So what we did. Okay, so I skip this. Okay, you can give a try later. But the one I teach you is today is this one. Okay, something new to be added. Okay, this is focusing to discharging a capacitor. Okay. When the circuit is above is connected to a terminal Q, when you connect to the terminal Q, the capacitor will discharge. Okay, the current flows this way. Current in the opposite direction is observed compared to the direction of the current flow during the charging process. When charging, and the capacitor is charging, current flowing down or upwards? Flow down across the capacitor, flowing up from the capacitor. And charging, the battery positive terminal is bottom, so current is flowing up across the capacitor, right? Current flow this way, right? When charging you connect where? You connect at P, right? You connect at P, current flow where? Current flow upwards, right? To the capacitor.
Then the battery is one hour down.
For you.
Three questions. So there's final battery in the middle.
Okay, upwards, positive. This is wrong. Upwards. Okay, so current flow upwards. Okay, down, up to down. Okay, then when discharging, when you connect to Q, current flow in the capacitor in opposite direction. Okay, and the charging current flow down to capacitor. Okay, when discharging, current will flow up. Right. Okay, so that's the second point. Current in the opposite direction is observed when discharging. Okay. Okay, now something new. The current, when current decreases, when current across the capacitor, across the micrometer which connected series with the capacitor, the current decreases, important, exponentially. Okay, the current decreases across the capacitor exponentially. Okay, so something new, These are the newly added. This is newly added to your syllabus. Okay, last year they don't have, so newly added. Okay. So the current when discharging, when the capacitor discharges, the current across the capacitor will decreases exponentially. The voltage across the capacitor also will decreases exponentially, and the charge across the capacitor also decreases exponentially. All three decreases, right, for capacitor. Voltage across the capacitor decreasing, the charge releasing, charge also decreasing, and the current in the circuit also decreases. All decreases exponentially. Okay, don't just say in exam decreases full stop, won't get marked. You must have decreases exponentially. Okay, so this is the formula. Okay, newly added in your syllabus. The new current at that moment, at a particular moment after discharging time t, okay, after 2 seconds after discharging, what is the remaining current? I equals to I naught E negative T over RC. Okay, formula, discharging formulas. So now in your exam, they can ask, what is the charge taught? What is the current? What is the voltage across the capacitor at any moment? Okay, during discharging. Okay, this is a formula to be used. So T must be in seconds. Okay, R is the resistance in the circuit. Okay, ohm. C is the capacitance in farad. All use SI unit. Okay, ohm, farad, second. Okay. Okay. So theoretically, the current going to be zero like an infinite time, right? Theoretically. Okay, the RC, right, in the equation, the R times C is called time constant. It's called time constant. Okay, so where's your time constant? This is called time constant, RC. It's called special name time constant. Okay, the product of resistance and the capacitor is known as time constant. Okay. So this is a very important term in capacitor. Okay, if the time constant is huge, if the R times C is huge, that means it takes a longer time to discharge. Okay, if RC is great, means it takes longer time to discharge. Okay, but there is a definition for a time constant. So this is the definition of time constant. What is time constant for a capacitor? Time constant is the time taken to discharge a capacitor to 37%. Drop to 37% of its initial value of charge, current, and voltage. So time constant is time taken for it to drop to 37%. Okay, original, let's say it has 100 coulomb, time taken for it to drop to 37 coulomb. That's time constant. Okay. So in the graph, if they give an exam, they might give you a graph. They'll ask you from the graph find the time constant. So 0.37, just cut, find this, whatever time you got, that's your time constant. And that time is equivalent to what? RC, R times C, resistance times capacitance. Okay. This newly added in your syllabus. So they can ask you, find the time constant from the graph. They can ask you the definition. What is time constant? Time taken for the discharging capacitor to decrease its charge, current, voltage to 37%. Its initial value. Big time constant means what? The discharge takes longer time. It takes longer time to discharge. Okay. So how do you discharge the capacitor to make it more longer? It depends to R and C. Okay. Use big resistance, use big capacitance, it discharges slowly. Okay. Big resistance, big capacitance, the discharging process takes longer time. That's a conclusion. That's all. Okay, so this is capacitance. Okay. Okay, so we stop here.
For the definition of the tau, we say it decreases to
1